Okay, this is for take 3.5e. Our question today is Carson was gathering candy together to create goodie bags for his neighborhood party. Create a table to help Carson figure out how many pieces of candy he would need for 5, 8, and 12 bags if every bag had 7 pieces of candy. Okay, so one thing I noticed this problem is asking us to do is it's asking us to create a table. So that's one of the things we need to notice, that we're going to be creating a table. I also noticed we need to know how many bags he's going to ultimately have. So the highest number is up to 12, but we would need to know how many pieces of candy he would need for 5, 8, and 12 bags if he had 7 pieces of candy in each bag. So one of the things it's important for us to notice is what we're counting by. So what are we going to be counting by today? We're going to be counting by 7s, okay? So when I think about this, I think, if I have 7 pieces of candy, I have that for 1 bag. But I need to create a table to help me figure out how many pieces of candy I would need for 5, 8, and 12 bags. So my relationship I can use is if I have 1 bag, I need to think about this, and that gets me 7 pieces of candy. I need to think about that relationship. So, 1 bag equals 7 pieces of candy. Well, what can I do to get that? So what is my relationship here? So I have 7 pieces of candy in each bag. 1 times 7 equals 7. So if I have 1 bag, so let me make a table. So over here I'm going to have my bags. Over here I'm going to have my amount of candy. Okay. So my highest number I'm going up to is 12. That's really important because my highest number I'm going up to is 12. However, maybe one of the things I am not able to do is count by 7s, okay? So if I need a table that gives me 5 bags, 8 bags, and 12 bags, well, my relationship goes across, okay? So I would need to multiply 7 by 7 each time. However, in 3rd grade, at this time of the year, many kids aren't quite fluent with multiplying by 7 yet. So one of the things we can do to help them with this, and also as a check for them, is for them to be counting by 7. So I can come over here and make a T-chart for counting by 7s. When I do this, I want to make sure that I put some dots up here. 1, 2, 3, 4, 5, 6, 7. Okay? I notice that my highest number is 12. Okay? So down this side, this is going to represent my bags. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? And then I'm going to have lines going across over here to help me get there. So I'm going to start out. What is my relationship? I'm going to multiply. So I know that 1 times 7 is 7. Most kids may even know 2 times 7 is 14. 3 times 7. Here's where I need to start. Then my strategy would come in. I just left off at 14. So 15, 16, 17, 18, 19, 20, 21. So 3 times 7 is 21. Then I'd keep going on if I needed to. 22, 23, 24, 25, 26, 27, 28. Maybe I knew 7 times 5 is 35, but I needed to pick right up 36, 37, 38, 39, 40, 41, 42. Maybe I knew 7 times 7 was 49, 56. If I needed to, I could come up here. 57, 58, 59, 60, 61, 62, 63. Okay, I know that's 70, 77. Maybe I need to pick up right here. 78, 79, 80, 81, 82, 83, 84. Okay, so when I'm using this strategy though, I need to come over here and ask myself, bags. Which ones do I need? Well, I need to know about 5 bags. I need to know about 8 bags. And then I need to know about 12 bags. So I can say 5 times 7 is 35. 5 times 8 is 56. 12 times 7 is 84. So I'm going to say my bags times 7 equals the amount of candy. Okay, one thing to look for misconceptions wise with kids is, well, a couple of things. Over here you'll notice I picked something that's not counting by ones. So a lot of times kids will say 5 and they'll equate this to be 6. And so if you see the answer over here is 42, it's because they're not going across, they're going down vertically. So the relationship, you want to always make sure it goes across. Now, sometimes the relationship is multiplication, but sometimes the relationship is addition. And you want to say, in those cases, okay, well, did it work every time? Every time, did I multiply by 7 to get my answer? And in this case, we've already done that check, so yes. All right, so this is just the very beginning of 3.5e for tables, the input and output tables.